I am going to explain about arithmetic group of instruction. These instruction can perform operations like addition, subtraction, increment or decrement. First of all, let's discuss addition. Any 8-bit number or the content of registers or the content of memory location can be added to the content of accumulator. After addition or early operation, the result is available in accumulator. As the addition is an early operation, all flags are modified to reflect the result of addition. It is to be noted that no two other 8-bit registers can be added directly. In order to perform addition, one operand should be there in accumulator, another operand may be a direct 8-bit data or content of any other registers or the content of memory location. We can't perform the addition between B register and C register. In order to perform this addition, that is the content of B register is to be added to content of C register. In order to perform that one, first of all, we need to move either B content or C content into accumulator. Then we can perform addition. Next is subtraction. Here also any 8-bit number or the content of register or the content of memory location can be subtracted from the content of accumulator. And finally, the result is stored in accumulator. As it is an early operation, all the flags are modified to reflect the result of subtraction. It is to be noted that subtraction is performed in two complement form. If the result is negative, it is stored in 2's complement form. Just like addition operation, no two other 8-bit registers can be subtracted directly. Instead, one of the operands we need to move into accumulator. Then we can perform subtraction. Next one is increment or decrement. The 8-bit content of a register or memory location can be incremented or decremented by 1. The 16-bit content of register pair can be incremented or decremented by 1. Increment or decrement can be performed on any register or a memory location. All flags except carry flags are modified to reflect the result of increment or decrement. Now let's see the first instruction in arithmetic operation, that is AddRS. Whenever this instruction is executed, the content of specified register, that is get added with content of accumulator, and the result is saved in accumulator. These registers may be any one of the general purpose registers B, C, D, E, H and L. So as we can have 6 general purpose registers and 1 accumulator, number of instruction coming in this category is 7. As the operands are specified in any one of the general purpose registers, this type of addressing mode is register addressing mode. When we are converting this instruction into machine code, the opcode size is 1 byte long. Therefore, this instruction fall under the category of 1 byte instruction. So here we are storing the opcode of this instruction in memory that we need to take into instruction register. That operation is known as opcode fetch. So MUP need to communicate with memory in order to take opcode of the instruction only. Therefore, in order to complete the execution of this instruction, it requires only 1 machine cycle. And for opcode fetch, usually number of t-state is 4. Now let's see one example. Here example is AddE. Whenever this instruction is executed, content of E register is added with content of accumulator and the result is saved in accumulator. All flags are affected. Let's assume initial content of accumulator as C2 and initial content of E registers as B8, and all flags are initially assumed as zeros. So when we are performing the addition, so C2 we can convert into binary like this, B8 we can convert binary like this, After performing addition, the sum is obtained as 7a and carry is obtained as 1. After completion of this execution, the content of accumulator will be the sum. What is the sum? 7a. And there is no change in the content of E, that is retained as B8. Now let's see how flags are affected. Initially all flags are zeros. First of all, let's see carry flag. Here carry is there, therefore carry flag will set. Let's check whether the parity is even or not. As the number of ones in this result is 5, it is odd parity, so parity flag will not set. There is no carry from LS be enabled to MS be enabled, therefore auxiliary flag won't set. The result is not 0, therefore 0 flag is 0, reset. Then sign flag MSB of the result is 0, therefore sign flag is 0. Next instruction is AddM. Whenever this instruction is executed, the content of memory location whose address is available in HL register pair is get added with the content of accumulator and the result is saved in accumulator. In 8085 there is only one instruction in this category. As the address of the operand is not directly given in the instruction, instead it is specified in register pair, this type of addressing mode is register indirect addressing mode. When we are converting this instruction into machine code, the machine code size is 1 byte long, therefore this instruction is a 1 byte instruction. In this instruction, we are saving the opcode of this instruction in memory location 1 that we need to take inside MUP to instruction registers. That process is known as opcode fetch. So after opcode fetch, MUP need to take the content of the memory location pointed by HL pair in order to perform addition with content of accumulator. So that operation is known as memory read. So in order to complete the execution of this instruction, it requires two machine cycles. One is opcode fetch and another one is memory read. For opcode fetch, number of t-state required is 4 and for memory read, number of t-state required is 3. So totally t-state required in order to complete the execution of this instruction is 7. As it is belongs to arithmetic and logical operation, all flags are affected. Let's see one example. Let initially the content of accumulator be 44H and the memory location C00A is having the content 73H. So whenever AddM instruction is executed, content of memory location pointed by HL pair, that is 73, is get added with the 44 and the result is saved in accumulator. Say initially the content of accumulator is 44. The content of memory pointed by HL pair is 73. When we are performing this addition like this, we can obtain the sum as B7. There is no carry. Therefore, the result B7 is saved in accumulator and the content of HL pair and the content of memory location pointed by HL pair don't alter. Now let's see the flag status before and after execution. Initially we are assuming that all flags are zeros. Since there is no carry flag is 0. Let's see number of ones. Here 6 ones are there. 6 is an even number, therefore even parity, therefore parity flag will set. There is no auxiliary carry, therefore auxiliary carry flag will reset. Answer is not 0, therefore 0 flag is 0. Let's see sign flag. What is the MSB? MSB is 1, therefore sign flag is 1. Next instruction in this category is ADI data 18. Whenever this instruction is executed, the data which is directly given in the instruction itself is added with content of accumulator and the result is saved in accumulator. As the data for operation is directly given in the instruction itself, therefore this instruction is having immediate addressing mode. When we are converting this instruction into machine code, its size is 2 byte long. That is, first location we will save the opcode corresponding to this instruction and the next location we will save this data. So first of all, in order to execute this instruction, we need to take byte 1, that is opcode, from external memory to instruction register. That operation is known as opcode fetch. Then we need to take this data into inside MUP. That process is known as memory read. So in order to complete the execution of this instruction, it requires 2 machine cycles. For opcode fetch, number of t-state required is 4, and for memory read, number of t-state required is 3. Total t-state is 7. As we are converting this instruction into machine code, it requires 2 consecutive locations. Therefore, number of bytes is 2. It is a 2-byte instruction. As it belongs to ALU operation, all flags are affected.